Okay, we're doing this book again, Prevent and Reverse Obesity by me, Pete Rogers. We're on page 67 if you're following along in the book. So what we were talking about is how high-fat foods are bad for your health, okay? And all the fats are bad. There's no such thing as good fat in terms of dietary fats. This was the experiments originally of Peter Quoll, the cardiologist in Pennsylvania in the 1950s with sat fat. Later, similar experiments were repeated by him, especially by Ray Rosenman and Meyer Friedman. What they showed was all the fats are bad. Okay, when you eat a carbohydrate, that's like a starch, the green line here, you don't get a spike in your blood lipids. When you're just eating starches, they got the fiber in them, so they're slowly absorbed. This is not like a simple sugar soda pop or something where you'll get a spike in your blood glucose and you'll get elevated triglycerides. All right, so anyways, they would check the lipids every 30 minutes, and after eating saturated fat or eating PUFAs, polyunsaturated fat, like cooking oils, they would get this major increase in their blood lipids, and they would get chest pain. Cardiac angina patients at the time of peak lipidemia was a characteristic finding. And the unsaturated fats, so the cooking oils, were even worse for prolonging blood sludge, sticking together the red blood cells. So you're not going to win with the fats, because there was initially some hope that maybe the PUFAs would be significantly better, but they're not. Okay, sorry, I got to scroll through this. Okay, this is just a diagram to show you, over 99% of the cells in your blood are red blood cells. So when the fats stick in the red blood cells together, that's a big problem. The blood becomes thicker. That's called increased viscosity blood. It's also called blood sludge, rouleau formation, stack of coins in French. Okay, you'll be able to see it. I'll show you a picture of it. There was a good movie called The Game Changers talking about vegan diets and athletes. And one of the things they showed was a blood test tube after drawing blood. And you'll see that the plasma, normally it's translucent, you can see through it, but after they eat a high-fat meal, it becomes thick with the fat, the chylomicrons. So that's not good. You don't want your blood to be all thick. It's going to have a harder time getting through the capillaries. The red blood cells already 7 microns in diameter, and the capillary is only 5 microns in diameter. So when they're all stuck together with the fat, it's like pushing a blob of fat through your capillaries. That decreases oxygen delivery to the tissues. That's not good. Okay, here shows you some of the problems with the PUFAs, polyunsaturated fatty acids. So a PUFA means polyunsaturated, more than one double bond. A single double bond would be a monounsaturated fat, a MUFA, like a MUFA here. Okay, when there's a PUFA, 2 double bonds, there's in between a skip carbon called a methylene bridge, because a carbon, imagine I'm a carbon, and then there's a hydrogen, there's one bond each way to a carbon, then a hydrogen above and below coming off. Each carbon holds 4 bonds. That's called the methylene bridge carbon. It'll be CH2, and then bound to the carbon in each direction. The double bonds are pulling on the electrons, so this hydrogen can be plucked off and oxygen can bind to it. 2 oxygens in a row is a peroxyl, okay? So this is lipid because it's a fat, peroxidation. Okay, and then there's an unpaired electron in the outer orbital. That's called a free radical. So that's very prone to what are called lipid peroxidation reactions, which are free radical reactions. It initiates chain reactions. These can destroy plasma membranes, and they can destroy DNA. They can destroy other tissues. So there's a propensity, a tendency of omega-3 and omega-6 fats to cause these. And the longer the chain, the more double bonds, the worse it gets. That's why if you're at least eating the low-fat plant foods, you'll get the least unsaturated versions of the preliminary fats that can be later be made into the long-chain ones if you need them. But if you supplement with the long-chain ones from the get-go, they're much more prone to rancidity and these lipid peroxidation reactions. And that's another reason why do they tell people they're put in a radio-opaque bottle and told to store them in the fridge right away, okay? And you can imagine how prone they are to lipid peroxidation in the higher temperatures of your gut and your blood, okay? Omega-3s are associated with increased risk of atrial fibrillation, increased risk of prostate cancer, obesity, and eventually they'll also cause insulin resistance. They're not something that you need. Okay, this is a diagram of the Yamashima theory. Tetsumori Yamashima, MD, PhD, Japanese neuroscientist, given the task, why are so many Japanese people become demented? And he figured it out. He says it's because they're now eating too much fried food, too much cooking oils. Okay, and I can tell you, I sort of one of the people who figured out the people from India, okay? Why is it you meet all these people from India and you first meet them and they look pretty good. They're skinny, they look pretty healthy, and then you start talking and they're like, well, I got diabetes, I got coronary artery disease. And you're like, how the hell did that happen? You're a skinny looking vegetarian and you walk a lot. And they're like, I don't know. And I start talking to them and they tell me they eat this fried food and stuff. Like I told you, I had a cardiologist friend, really nice guy. And I hadn't seen him for a couple months. And I said, hey, where you been, And he goes, I was dead. I go, what do you mean you were dead? He goes, I was dead. I died. I had to be defibrillated, resuscitated. He had a heart attack. Okay, and I'm like, how did you have a heart attack? You're a skinny vegetarian who walks all the time. And he goes, I don't know. Must be congenital, small coronary arteries. I said, that's bullshit. And then I said, do you put oil on your food when you cook? And he goes, yeah, of course. How else are you going to cook? I go, no, you don't need to do that. That was the answer right there. He didn't have any other dietary sins. Okay, these oils are much worse. Dr. McDougall said it. The excess fats in the Western diet are the number one toxin, okay? And these oils, they're toxic to your blood vessels. They're toxic to your gut line. They're not even a food. They're this chemical processed thing. Okay, and that goes for extra virgin olive oil, okay? It's better for a lubricant than it is for being put in your mouth. Okay, now here's the Tetsuya Yamashima theory. It's called the calpain-cathepsin theory of neurodegeneration, all right? So what happens is there's a byproduct, metabolic byproduct of the lipid peroxidation reactions called HNE, hydroxynonenal. And by the way, I've given other lectures where I go over all this stuff in much more detail, but just for the sake of going through some of these theories of why do people get fat and sick when they eat these Western diets. The hydroxynonenal binds something called HSP inside of your brain cells, your neurons. That's called a heat shock protein. The heat shock protein normally has a job. It's a chaperone to carry dysfunctional proteins over to the lysosome, the recycling plant of a cell, so they can be recycled, that their constituent amino acids can be used for other things. But when hydroxynonenal, HNE, binds to HSP, the heat shock protein, it makes it attractive to calpain. Calpain is just like its name says. It's activated by calcium, and it's painful. It has painful consequences. It's a protease, meaning it chops up proteins. So calpain will chop up heat shock protein, and then the heat shock protein can't do its job, so the dysfunctional proteins start piling up. They can't be taken to the lysosome. Plus, the heat shock protein used to stabilize the lysosome's membrane. So now the lysosome breaks apart, and it spills its digestive enzymes, its protease, cathepsin protease enzyme, and it starts eating up the cell. It's kind of like having pancreatitis, intracellular pancreatitis. The digestive enzymes of the pancreas release in certain conditions, and the cell just digests itself and it dies. Okay, so you don't want that. You destroy enough brain cells like that, your IQ starts going down. That's why he thinks so many Japanese are getting demented compared to how it used to be. Okay, I think that's enough for today. I hope you found that helpful.